Last year, as I mentioned, we worked with several journalists on projects where the written or spoken or official word was at odds with what teams of journalists were documenting on the ground. In our project with Inside Climate News, shown here, we brought our tech into the field, sending photojournalist Pablo Albaranga to document and create a quote-unquote time capsule of the Pantanal, Brazil's largest wetland, the scene of devastating fires. Inside Climate News was eager to work with us because, as the editor said, quote, on top of the environmental challenges Brazil faces, it's also confronting a pair of destructive forces that are challenging journalism: the contradiction of fact-based information and the denial of climate change, end quote. This story examined the impact of both. Photos presented by the Inside Climate News coverage provide a clear window into the environmental crisis. They go further by displaying data that proves their provenance, creating an unalterable, quote-unquote, time capsule of the events captured in the images. The story demonstrated the use of new technologies to confront visual disinformation. And as you can see, the scenes on the ground stand in marked contrast to the political rhetoric and misinformation spread by former President Jair Bolsonaro, who lost his presidential bid shortly after this story ran. So how did we do this? The problem we faced: news publications often use high-end cameras that don't capture enough metadata to fully authenticate digital assets, nor adequately identify who created an image. To solve that, we turned to cryptography and decentralized tools. What we did was develop a hack, if you will. Using Wi-Fi, we tethered a high-end Canon camera to a special phone outfitted with a sophisticated chip to sign assets. Our team developed an open-source Starling Capture app for the phone, which allowed these systems to talk to each other and record authenticity and identity details. Photos moved to the phone when shot and were simultaneously hashed and signed. They were then registered on decentralized networks or blockchains. Stored there, the hash, or digital fingerprint, allows users to track the history or provenance of the photo. If anyone has manipulated the image, running it through the formula that created the original hash, the original ID number, will produce a mismatched number, indicating the image has been changed. To be sure, you can see this was a clunky process, requiring some maneuvering on the part of our photographers. Still, having tried this out, we got good results, and now we're building on what we need to do to make these approaches more convenient.